Hello everyone, welcome to another video with Cast on the Maizuma Games channel. In today's video, I would like to share my findings related to a interesting redstone behavior that I had to deal with this week. And I promise you, I'm gonna show you some really cool stuff. Everything started because I wanted to build some sort of filter for one-tick pulses. So just to make sure everybody's on the same page here, I'm just gonna quickly mention why one-tick pulses are special in Minecraft. Normally, if you send any sort of pulse to pistons, they're going to extend and retract, as you can see here. But one-tick pulses are special because they can make pistons behave differently. I can get a one-tick pulse from a observer by interacting with this node block here, and now the piston leaves the block behind. We can also retract it using this. And another simple way of getting a one-tick pulse is, well, we're still going to use the observer, but now the pulse is going to come through a repeater, which is also set on one tick, so same behavior. Not all components respond to one-tick pulses though, so as you can see, if I press the button again, both the redstone torch as well as the redstone lamp are going to respond to the pulse. But if I send a short pulse from the observer or from the repeater, neither the redstone torch or the lamp is going to respond. So, as I was saying, I was trying to do something with one-tick pulses when I realized that if the one-tick pulse comes from the repeater, the lamp turns on, but if the same one-tick pulse comes from the observer, the lamp doesn't turn on. Since all we're trying to do here is to just send a one-tick pulse to our output device on the other side, I really expected those two devices to behave exactly the same, which is obviously not happening. So my next course of action was to try and consult with a specialist, so I decided to bug my good friend Spacewalker. He speaks in a language which is unsuitable for us simple mortals. But anyways, he helped me eliminate some variables and make sure that the kind of behavior that I'm trying to analyze can be replicated anywhere. So I would say the next very important question is, from the perspective of a redstone component connected to a redstone wire, are redstone components able to tell when a signal is being sent from a repeater or when it's being sent from an observer? Well, check this one out, guys. We still have the same single wire kind of setup here, and if we fire it from the right side, the right lamp turns on. If we hit it from the left side, left lamp turns on. And what is really fascinating about it is that we are not using any of the traditional properties of signals and pulses, because we are not using information about pulse length or signal strength values. We are basically sending the same kind of pulse, and the difference is the same pulse can be created by the repeater or by the observer, and we do have a circuit that can tell those apart. And not only that, notice that when the pulse comes from the observer, the output also goes through the observer, as you can see here. And if it comes from the repeater, the output also comes from the repeater. So maybe we are going to be able to chain more of these. So I created this simple network to test if this kind of source detection can be propagated. Once again, if we fire the observer, we're going to get a pulse from the right side. And if we fire the repeater, we're going to get a pulse from the left side. And you can see that the signal indeed is propagated here. And this is so interesting, guys. So my next step was to try and modify this kind of network. And I came up with this little experiment here. If I now hit the observer, you will notice that the signal doesn't get propagated. By the way, we are trying to see if the signal can go all the way around through these. As you can see, if we fire, what I'm saying is we're basically able to build an entire redstone network here that is capable of refusing pulses if they come from observers, but pulses coming from repeaters are accepted. You can see here that we are literally crossing wires here and here with another filter device here. And then if I hit this button, notice how this lamp now turns on, but not this one. So we are literally able to cross wires with this kind of setup without getting any kind of interference. And look how crazy it is. If I send a signal through this button here, the signal gets immediately blocked and is not propagated through the network, which makes me think that maybe we can use this kind of behavior to prevent interference from other kinds of signals trying to get into your network. I also spent some time testing it for kind of all sorts of different pulses here, and I don't want to dive into the madness of all of it, so I'm just going to quickly mention that this experiment is just like this main line here being connected to our splitter repeater, and here I'm trying to see what's going to generate a orange pulse or a red pulse. So we have these red circuits on this side and the orange circuits on this side. Basically, the network responds to whatever pulse is longer than one tick pulse, or if it's a one tick pulse, but from an observer, it's going to be an orange pulse. And anything between 0 and 2 game ticks is going to be a red pulse. It also turns out that there's more than orange and red, but maybe this is going to be the subject for a different video. Let's now take one step back and run a simple experiment again. What I'm trying to do here is to create a sequence of pulses here. But with this sequence, the first pulse is going to be from a observer, then we're going to get 3 pulses from repeaters, followed by yet another pulse from a observer. So inside this dispenser, I have a bunch of firework rockets, and here we have fire charges. So we're expecting to see a rocket followed by 3 fire charges, followed by yet another rocket. Maybe if I slow down the game a little bit, it would be a little bit better to see. So if I flick the lever now, rocket, fire charge, 3 times, and rocket again. Looks like we are able to generate pulse sequences from all of this. What? Giant redstone machine at the back? No, I can't really see anything in the background. So this next example is a slightly more sophisticated version of the same thing you just saw. But instead of having a hard-coded sequence here, we can actually set up the sequence using these levers here. And instead of having this kind of output where we have fireworks and fire charges, we actually have lamps and a memory device. So a simple example would be to set the first bit and the last 2 bits here, just so it's easy to memorize. And when we press the button, you can see a bunch of pulses being transmitted to the redstone line, and then they're being transmitted through the receiving end of this thing. And then, as you can see, the pattern has been replicated with the first bit set and the 2 last ones. There's nothing exactly new about transmitting serial information in Minecraft, but the way this is done is actually different. As you saw, the first device is our transmitter, and it's going to transmit signals to this repeater here, which we also know that can be replicated. This is just to show that this redstone line here can be extended, and these signals can be sent to far distances. And finally, we get the receiver here responsible for making out what the pulses are. What usually happens is we need to send a pulse to kind of wake up the device. Once it happens, the receiver knows that data is coming next. It knows how many bits to expect, and then after as many bits, it's going to lock itself. And it does this by using this setup here with this, by locking and unlocking this redstone line here, it's able to lock information in place. The machine is definitely capable of detecting when a signal is being transmitted that is supposed to turn a lamp on, or if it's just an inactive transmission line. With this new one, since we are able to tell the difference between pulses coming from repeaters and observers, this is exactly what the decoding system does. If I hit this observer here, it's going to register this as a 1. If I can do it again, so see, 1, 1. And I can send a 0 as well, as a 1-tick pulse, and it's going to register as a lamp off or 0. So see, 0, 1. So basically, this works as a shift register that responds to incoming data. And not only that, if I flick this lever now, see, nothing happens to the receiver. If you keep looking at the lamps while I flick the lever, see, this lever is not going to interfere with anything as long as the signal coming from it is longer than 2 redstone ticks. But in terms of serial data transfer, this is a device that doesn't need to know how many bits it's going to receive in advance. So you don't need to hard code how many bits it needs to receive. It's amazing. The only downside for this specific design is speed, since we need to space the pulses apart every 4 ticks, which is why we have these repeaters here. This is something I try to address with my next example. This is the new setup I came up with, and let's run a quick test here. Same exact test, actually, where we set the first bit and the 2 last ones. Hit the button to send information, and you can already see the difference. This is so much faster. Look at this, guys. We don't have to use this repeater chain here. Instead, we're just using a observer chain, which means that we're going to send pulses every redstone tick instead of every 4 redstone ticks. You can see that I had to redesign the redstone here in order to make this device so much faster than before. This is also because we are using a different method for this arrangement here. So if I remove these blocks here, you can see what's going on. We're back to using the method that wakes up the receiver. So what we're doing is we're using a observer here to tell the device to unlock. By unlock, I mean all of these repeaters here responsible for storing information are locked. We're basically telling, hey, can you unlock the repeaters? All right. Next up, we're going to send information using the repeaters, which is much easier to do. And in the very end, we're going to switch to observers again. And this is going to tell the system to lock all the information in at the exact precise time required for the information to be stored. As a result, now we got the advantage of speed with this thing being 4 times faster than before. Let's do another demonstration here. And we also don't have to hard code the size of the thing we're trying to send because the transmitter is capable of telling the receiver. The downside now is, unfortunately, this doesn't work with this very important component here, which is the repeater, or the splitter repeater. The splitter repeater is apparently too slow to deal with this, and I wasn't able to quickly design a new one. So meanwhile, what I tried to do is to find a practical example where short range would be still relevant. Oh wow, apparently you guys were right the first time. There seems to be really something at the background that I failed to recognize before. Well, let's maybe talk about it now. So what I built here is a device capable of storing shapes. So you can use it to store numbers and arrows and emoticons and letters from the alphabet, or maybe just... So before anything, I need to apologize for this video being laggy or choppy at all. My current gaming setup is not adequate for recording videos, unfortunately. Alright, so let me show you how this device works because it's actually pretty cool. So what we have here is a board where we can draw shapes, and then we can basically store the shapes inside the main screen. Let's do a traditional Reaper face here. If we hit this button now, you can see that everything's going to move to the side, and then we're going to have our creeper face right there. Now let's draw a small X shape. Hit the button. And there we go. And we can keep replicating the same shape that we have here as many times as we want. And here's a useful pattern for what I'm trying to demonstrate with the other buttons here. So if I hit the same button again, we're going to get some sort of staircase here. But I don't need to send all of these columns at once. I can maybe just send 4 of those if I hit this button here instead of 5. And you will notice now that we have 1 less column compared to the previous one. Or maybe we can send only 3 columns. Or maybe 2. Or maybe just 1. We can also send a blank pattern, so we can use this to space things, see? Or we can just do it 5 wide. And as you can see on the other end, information just disappears. But if we want all the information to really disappear, we can hit this button, and the activity lamp, or LED, is going to basically tell you while it's operating. And you can see that all the lamps are being turned off, and when it's done, the lamp turns off. And you got a clear screen. Here's the redstone behind everything, but because we're going to run out of time, and because this is going to be absolutely laggy for me to record now with all this redstone here, well, the game is not laggy for me, but recording is. I'm just going to mention what each component is. So this is our drawing board. It basically reads the input from the node blocks, and it powers the lamps at the front, and it also moves these trapdoors to this part of the circuit. These ones back here are the serial data encoders, converting from parallel to serial with this. And here you can see that I just basically stacked a bunch of serial transmitters because I was maybe being lazy, I don't know. Then we got the magenta circuit, which reads by how many columns we want the system to shift the memory device here. And there's only one exception, which is when we hit the reset button. Then we activate the brown circuit here, which is basically going to empower this redstone line for as long as there are items inside this hopper here. This big section here is mostly pixels being wired, and I'm trying to make sure that these repeaters are on 4 ticks to try and reduce a little bit of lag. And I'm also using blocks that can emit light so that light updates can be reduced. And we have some instant repeaters that don't seem to be as instant as I expected. And that was our video for today. I hope that I was able to entertain you for a little while, and I would really appreciate it if you could hit that like button to help my channel. And once again, big thanks to my patrons and supporters in general who have been supporting me on YouTube, since YouTube itself is not going to work for me, is it? Anyways, guys, thank you very much for watching, and I hope to see you soon. Goodbye. Take care.